Great to speak to you on this very complex topic. I am going to just really run through some concepts that I hope you can follow to help us think about why disparities, inequities in cancer and in general are very complex and how we can begin to think about them, perhaps in a more nuanced way. So let me just start by talking a little bit about where disparities come from. And this is work that Hilary Graham and colleagues presented many, many years ago now, that disparities are really the consequence of differences among groups. So genetics, race, ethnicity, behavior in the environment, biology, physiology, many, and these are a few of the very many categories that we could begin to think about. Disparities are also the consequence of inequities in society, and particularly in the United States, the consequences of systemic racism that impact on care and access, discrimination, segregation. Again, it's a very long list. I'm putting a few things here that I think are quite relevant. When we want to think about where disparities come from and then how to eliminate them, we can think about whether there are some factors that help us to stratify individuals on their risk. So genetics, race, ethnicity, to some degree environment are not things we necessarily can change in some cases, most cases in genetics, et cetera. But we can identify people who are at different levels of risk because of differences that are innate to them. And that might help us identify populations of need. But we also want to think about interventions. We want to think about what the behaviors, the environments, the biology, the physiology, the care access, discrimination, segregation, et cetera, the things that we might be able to ultimately intervene on. And of course, none of these things are easy to intervene on, but if we want to think about how we might intervene, this is one way to think about it. So I'm going to use the example of prostate cancer today, primarily because this is an area of my work, the focus of my work these days, but also because it really represents a great example of disparities and how complex disparities are, and that there are a lot of different aspects of the disparity we might need to think about it in order to eliminate it. So prostate cancer in this map is in the green is the leading cancer in incidence in many parts of the world, as you can see here. But it's also has an incredible disparity in the United States between African Americans having much higher incidence and mortality compared to European Americans, and Asians having more favorable incidence and mortality compared to European Americans. So there's quite a bit that can be said about the need for a understanding and eliminating these disparities, because this is one of the biggest disparities of a common cancer that we know of. And unfortunately, there are not a lot of incontrovertible risk factors, age, family history, race, and obesity for aggressive disease, but there are not a lot of exposures. And our department, our school has been the leader in identifying a lot of these risk factors. And so there are dietary, lifestyle kinds of exposures that matter, but they're much harder to confirm compared to a lot of cancers, colorectal cancer, breast cancer, other common cancers. They really do have very clear patterns of modifiable risk factors that we can use. And so prostate cancer is a little harder. I'm also going to talk a little bit about the work that we are doing globally in our MADCAP study, Men of African Descent and Carcinoma of the Prostate. This is an international study in the United States and across Africa, funded by the NCI and others. And so I'm just mentioning this as when you see that MADCAP logo, this is work that we've undertaken. It's ongoing, and we welcome other people who are interested in collaborating on these projects to get in touch, because there's a lot of work to do. So let me start with the framework that we can use to think about what these disparities may look like. And this is both simplistic and a little complex, so I'll walk through it. I'm going to focus today on the framework around self-identified race or ethnicity as the mark of the disparity. I'll talk a little bit about that. But we know that this self-identified race or ethnicity, or SIRE, is a consequence of culture, behavior, environment, social influences, but also our phenotypes, which are correlated with ancestry and genome-wide variation. So this ethnicity, race that we identify with it has a lot of correlates. And I just bring your attention to the double-sided arrows. We're not talking about causation. We're not talking about directionality. We're just talking about correlated or associated with. And the genomic variation in the genome is also associated with disease-causative genetic variation, tissue-specific changes in tumors and disease outcomes. And of course, I'll talk a little bit about interventions and how we can think about those in the context of all of these factors. So I'll just walk you through this, giving you examples of why disparities are complex and what we can do to think about them. So let me start with self-identified race or ethnicity, which is, again, really something that's a cultural, social definition, not a biological definition. And so just one first example of which there are many. Prostate cancer and its outcomes are really strongly influenced by social position, social determinants, and things like that. So here's just one piece of data that shows us the change in prostate cancer mortality by county level poverty. And this is comparing two time periods, 1970 to 74, prior to PSA screening, prior to a lot of the treatment options that are now available. And then in 2012 to 2016, after PSA became quite common, although during a period where PSA usage was very controversial and changing, but also after a period where there were many new treatments available for prostate cancer. So what you can see is in the 1970s, early 1970s, the mortality rate ratio between Blacks and whites for poor or affluent counties was similar between Blacks and whites, that poor and affluent counties really didn't change a lot, weren't very different. But by 2012, 2016, we see that county residents actually does matter. Blacks had a much less favorable cancer mortality than they did 30 years prior to that. And so that's telling us that social factors, social determinants are very important. This is obviously ecological data, so we don't know a lot about what this actually means, but you can imagine the kinds of things that are going on during this period of time. And certainly hidden in this plot are the implication that PSA screening, early detection of cancer was not equitably distributed, and that novel treatments that might improve longevity were not equitably distributed between Blacks and whites or poor or affluent counties. So when we think about that, that's the big context. There's a lot of social determinants that affect outcomes or prostate cancer risk, but the race and ethnicity itself has a lot to do with much more complex factors that include ancestry and genetics. And so how does that all fit in? So let me just make one statement that sire is a social construct. I think we all agree with that. I don't know anybody who feels differently about that. And sire and the disparities are a consequence of longstanding systemic racism in our country. So this is just one slide that sort of shows what that means in a very simple way. This is the US Census. So in 1790, that you could be free or slave, which essentially meant Black or white. In 1860, you could be mulatto, mixed race. And by 1890, you could be white, Black, mulatto, Chinese or Japanese, reflecting immigration patterns, and then quadroon or octroon, which reflect how much African ancestry you had, 1/4, 1/8. And by 1900, that changed to sort of the one drop rule. If you had any African ancestry, you were Black. And then by 1900, also Native Americans, American Indians were included in the census. So they literally didn't count up until that point. But more recently, we have the categories that you're used to seeing, that you could check multiple boxes and you can be Hispanic or not, et cetera. So this, is the framework around which our society is based, the social construct of race, but also how we often do research. So that last line, 2000, year 2000 plus, we often categorize people in these very broad groupings. And that may or may not be the right thing to do. And so we know that, for example, the African diaspora, the slave trade across the Atlantic, led people through enforced slavery from Africa into the New World. We, a few years ago, did an analysis that showed the genomic origins, a genomic ancestry of individuals who were self-identified as Black in the New World. And you can see the blue from West Africa, the red from Southwest Africa, and the yellow from Southeast Africa. There's a lot of variation in the genome, depending on where your ancestors came from. And so this, we often think of this large socially determined category of Black, African American, whatever, as being a monolithic group, but of course it's not. Again, I think we all know that, but we often in our research treat everybody who checks a particular box on the census form the same way. And we compare the groups to identify and understand disparities, and they are not the same. And there's a lot of variation. And if we look at, this is the percent non-African ancestry in self-identified Black men from our MADCAP group from a few years ago. And you can just see across the country, this is a histogram with the percentage of non-African ancestry. So you can see in Senegal, most men are African ancestry, but even in the United States, you see a huge amount of variation. And you see some people who have no African ancestry. If you look at Baltimore or St. Louis, there's a few people who self-identify as African American, but really have almost no African ancestry based on the metrics that we use. So I just raise these points to say that using a comparison of Black versus white is not wrong necessarily, but it really depends on the question you want to answer and how you want to address these problems. And so does this variation matter? This is work that Hari Iyer did. Hari is, I think, on the call today, on the Zoom today. So Hari, forgive me if I butcher your great work, but Hari did asked a question. So when does ancestry matter relative to social determinants? And so his work involved putting together a directed acyclic graph, a DAG, to ask whether increased African genetic ancestry causes, and we put in quote, increased mortality, overall mortality. And you can see the DAG here. I won't go into it a lot of detail, but it essentially says that genetic ancestry causes or is the driver of self-identified race or ethnicity, which then leads to a variety of factors and all-cause mortality. But of course, an alternative DAG, this one, actually asks what the role of social determinants are and whether they're important. So you can see it's slightly different. We have history, meaning in particular when we talk about Black-white differences, the consequences of systemic racism and the transatlantic slave trade, socially assigned race, and then its impact on all-cause mortality. So Hari did an evaluation of the PLCO data, that African Americans, and he found the following, that the effect of confounders on all-cause mortality and neighborhood socioeconomic status, a geospatial metric of social impact. And as you can see, when we did our first DAG of ancestry, there was an effect of percent African ancestry on overall mortality, but once we adjusted for a number of factors that were associated with social variables et cetera, the effect went away in the ancestry-only model, but remained in the social determinants model. So what we inferred from this is that neighborhood socioeconomic status may be causally related to all-cause mortality, but genetic ancestry maybe not so much. So this is just one piece of data that we're starting to think about. Is it social? Is it genetic? What are the social determinants that matter? And how do we begin to think about race and ethnicity when we want to understand and then eliminate disparities? So I think that we need to start thinking about race and ethnicity as a complex multifactorial trait. What do we need to measure? Do we need to measure self-identification, ancestry, socio-demographic traits, some composite metric? And I think that we need to start thinking that the appropriate definition of the comparison groups is really very important. We want to avoid misclassification bias and think about translation. So we might want to, we need to think more carefully and creatively about what the question is. What are we trying to achieve, and how do we want to achieve it when we want to measure a disparity? Other metrics like ancestry may inform the causes of disparities, but they may not be helpful for implementation. So if you have a patient walking into a doctor's office and we don't know their ancestral genome, but we do know what they self-identify as, obviously that might be the most important consideration. Self-identification may be what we care about, and those may need to be the studies that we do. Sire-based approaches, however, may not necessarily be the goal, because we often do research where we are asking, is there an effect in Blacks? Is it different than in whites, et cetera? But one of the things we do want to avoid, or we want to think very carefully about before we do this, is creating race-based medicine. And there are a lot of examples in the literature and in science about creating drugs that work for African Americans or whatever, and that has not been successful, first of all, and probably for good reason. But we don't want to start thinking necessarily that Blacks need to have this drug or that preventive strategy. What we're talking more about is tweaking, modifying the strategies so that they have the benefit for the populations of need. And that might mean access as opposed to a specific protocol. But those are all things to think about. So I think that most likely we're talking about group measures for discovery and then individual metrics for implementation. So we're looking maybe not at the person's overall race, but maybe a combination of their self-identified race, their history of comorbidities, their, whatever it might be when we actually go to implement it. So I just wanted to start out when with this talk, just to put a frame around how we might want to start thinking about disparities. And it's not simple, but I think that we in the field need to move beyond the way we have traditionally been thinking about disparities in self-identified race or ethnicity, and just more carefully identify the right way or the optimal way for a particular goal or question to address this problem. So let me move on just in the framework. We know that, as I mentioned before, there's a lot of phenotypic ancestral genomic variation that's related to disease causative genetic variation. And in prostate cancer, this is particularly important. And this is the slide I showed you before, but it has a new box in it. And that is that while there are not a lot of really easily modifiable factors for prostate cancer has a very strong heritability. One of the highest genetic contributions to the disease of any major cancer. And we have a lot of genome-wide association hits, 451 in the most recent report, meaning that there's a lot of genetic information. So again, genetic information may not be something we can use to intervene, but we might be able to risk stratify. We might be able to understand the goal of disparities and who might be more amenable to certain kinds of interventions to reduce the disparity. So and we know that what I just said is that genetics and biology play a role in etiology of prostate cancer. Do they play a role in disparities or thinking about disparities? So there are two simplistic hypotheses we can consider. One is that the fundamental etiology of disease differs by your self-identification. And I think that's very unlikely. I think that everybody's prostate cancer etiology, biologically and genetically, are probably fundamentally the same. There is not a biological difference between how you identify. But there are differences in frequency. There might be differences in the underlying genetic architecture of and the genetic distribution of risk may be context dependent, meaning the environmental exposures you find yourself in may impact on your own risk and the contribution of your genetics to it. So I think that we need to be thinking about what the role of any kind of biology genetics might be, but I think it's really kind of the second one, that we're not talking about a fundamental difference in carcinogenesis and its mechanisms by race or ethnicity, but something that is more subtle, but yet may teach us something. So where are we with this? Well, here's one piece of data that helps us understand how early these events occur. So these are data that we published many years ago now, that disparities exist even before diagnosis. So this is a summary of autopsy prevalence in latent prostate cancer, meaning these are autopsies that were done in men who died of other reasons, and they were broken out into Asian, European, and African descent men. As you can see, it's a fairly complex slide, but the prevalence of prostate cancer increases with age on the x-axis, as you can see. Interestingly, men of African descent, well, all men in their 30s have a reasonably high proportion of prostate cancer. So men are not diagnosed clinically with prostate cancer in their 30s, and wide error bars here. So that's, it's not perfect, but in European descent men, about 8% of men in their 30s had a prostate tumor. And so that means that these tumors are arising quite early. And these are all men, none of these men in this table were diagnosed. We see that in the 60s, Asian men have about an 18% prevalence of prostate cancer. European American descent men have about a 33% prevalence, but African descent men have about 56% prevalence. So this reflects what we see in diagnosed prostate cancer, the incident prostate cancer, that if it goes with the prevalence or the incidence that we see from diagnosed men. And we also see that, if you reach a 50% prevalence of disease in autopsy, that doesn't happen until you're in your 90s for Asian men. It happens in your 80s for European descent men. It happens in your 60s for African descent men. So the disparity is there even before diagnosis. So prevalence in this case of disease is not dependent on screening or on diagnosis, this is purely something that is inherently different about these men in terms of when their cancers arise, not are diagnosed. And so there's something that you might think is biological or environmental or something that is occurring differently by race. We know already, as I said, there are many studies now. The latest study has 451 GWAS hits for low penetrance genes, and there have been multi-ethnic genomic risk scores. This one by Conti et al. In 2021 that included 269 SNPs. These genomic risk scores tell us that compared with non-Hispanic whites, Blacks' genomic risk is shifted to the right, higher risk. Asians is shifted to the left, lower risk, and Hispanics are almost identical to non-Hispanic whites. So this, again, the genomic data that we've uncovered really fits with the prevalence data and the incidence data that Black men, African-American men by and large, from these data, really are impacted, really appear to have elevated risk. And this is, again, these are diagnosed men. So this might include the idea of prevalence of screening and things like that, or detection. But all of the data sort of align in saying that there are underlying factors that suggest Black men are likely to have the worst risk of all groups that we have identified so far. We've repeated the same thing. This is with work that we did in our MADCAP study, showing the same kind of effects in Africans, not the others were primarily African Americans. We see shifts from European to African populations, with African populations having much higher polygenic risk. And even within Africa, we see some differences. So I think that there is something going on genomically with underlying risk that might help us to understand the disparity. But one of the questions that we have, and this is something about translation, we want to understand who's at risk, but we also want to be able to take that information and modulate someone's risk, predict their risk better so that we can find them earlier, we can intensify their screening or whatever. We don't have a lot of data in African or African-American men, but we do have models like this. This is the Stockholm 3 model, and it's all white men, about 11,000 in the training cohort and 48,000 in the validation cohort from a few years ago. And what this study did is asked, what is the area under the curve, the predictive value, the biopsies saved if we incorporate knowledge about PSA, risk factors, biomarkers like genetic risk scores, and clinical information. So what you can see is that under the baseline model, the AUC is about 0.56. If you add in age, family history, and prior biopsies, it goes to 0.58. And when you add in the genetic risk scores, it only goes up to 0.6. So really small incremental increase in the area under the curve. So one of the things that I think many groups have been finding so far is that there's really very limited additional information of these PRS genomic risk scores that might help guide us into who is at higher risk once you've accounted for other things. And we don't have a substantive comparison yet for Black men, so we don't know if it's very different. It could be. And there have been a number of papers, I just mentioned one here by Sood, Turnbull, and Holston, that are really questioning the clinical value of genomic risk scores in addition to things we already know about the patient without genetics. And this is an area of active debate. And I don't want to make it sound like I don't think polygenic risk scores or genomic risk scores are unimportant, because they could be. We just don't have a good sense of that yet. And then as a result, how much it's going to impact on our ability to eliminate disparities. So we also see in tumors a lot of tissue-specific changes that suggest to us there's something biological going on. So these are data from our group that show, and I won't go into a lot of detail. This is on the left-hand side, the transcriptomic data, and the average transcriptomic distributions in African American men in the gold and European American men in the blue. And on the left, you can see there are significant immune signature differences, as well as radiation, DNA damage, repair, radiosensitivity differences between these different groups. And so we are beginning to get a pattern. This is our data, but there are other papers out there that suggest that African descent men, African American men, have a very different pattern of immune oncologic response or signatures, and they may be differently susceptible to radiation, radiosensitivity in treatment. So again, this is data that are suggesting to us there are biological differences by race. And on the right-hand side is another paper we wrote. Brandon Mahal was the first lead author a couple years ago, where we found a number of genetic profiles, and I show here the mutations in actionable genes. These are precision medicine, precision oncology genes, where we see the distribution. They're all the same genes, but the distribution of mutations that might direct a therapeutic target are very different depending on your self-identified race. And so again, we're beginning to see that the biology may or may not be the same, but there are certainly differences that might be guiding us about how to identify, how to treat, how to manage prostate cancer. Again, as you know, for prostate cancer, many of the tumors are early, they're indolent, and they don't need to be treated actively. They can undergo active surveillance. These data might actually help inform us about whether treatment for early low-risk disease may be useful or not. And these are things that are all ongoing discussion points. All right, pop quiz. So what is the best interpretation of the data that I just showed you? I just showed you genomic differences, genetic differences, polygenic risk score differences. What does that mean? So think about this. These data support the hypothesis that race is a biological construct. So, there are biological differences by race. So does that mean race is a biological construct? Knowledge of genetic differences can identify race-specific etiology and interventions. So, these are different tumors, different types of molecular signatures, different risks. Maybe we can identify different etiological patterns or interventions. Or third, C, knowledge of genetic variation across diverse populations is necessary to inform etiology and interventions. So if we were in a room together, I'd have a show of hands, but I think I probably made it clear earlier that race is not a biological construct. And I don't think these data, despite the fact that we see differences, support the hypothesis that race is a biological construct. Race, self-identified race and ethnicity, is a social construct for which there are genetic biological correlates that differ. And similarly, I think for B, we don't want to identify necessarily race-specific interventions, race-based medicine. I don't think that's the goal of this. It's not to say that it can't happen, but we really need to be very careful if that's the direction we take. But I think we can learn a lot about diversity across populations that will inform our etiology and interventions. And I think that's, to me, the reason that this biological genetic data has value. At least the main reason. And if they lead to something that are race-based interventions or something like that, then fine, but that isn't the goal. of the work that we're talking about here. It might happen, but it isn't necessarily why we're doing this work. So why is diversity important? This is another paper that we just came out from our group that asks about population transferability. So again, we have a genomic risk score, we have a screening test, and it's developed in white populations, but now we want to apply it in racially different populations, diverse populations. What are the pitfalls? And this is what this paper tries to address. This is data from MADCAP, our consortium, and from the UK Biobank, which are largely Caucasian. And you can see we have a whole series of polygenic risk scores by different authors and the ancestry in which they were developed. And so we can see that if you apply the data in the UK Biobank, mostly white, and that you get a certain area under the curve, and if you apply the same set of polygenic risk score to MADCAP Africans, you see that the area under the curve is worse all the time. That means that the discrimination, the ability to detect case from control is worse if you apply a score that was developed in one population, try to apply it to a different population. And we also see consistent bias toward the null hypothesis, that the odds ratio effect when applied in the UK Biobank is always higher than it is in the African population. So again, this goes to the point that I'm making, that data diversity is really critical. It might be that the odds ratio and the area under the curve are always worse, but it's more likely that if we actually created a polygenic risk score in MADCAP in African populations, it would work better than the scores that were generated from data outside of Africa or outside of the population we're trying to apply it. All right, so I'm trying to give you the flavor here of the framework and how it all fits together and what kinds of thoughts we need to give in order to do this work well and have it be meaningful. And the meaningful, I think, comes into the interventions that we might actually apply. We obviously want to identify tools and strategies and protocols that will ultimately be able to eliminate the disparity. So let me walk through a little bit of what we know about interventions in African American and African men and how we need to improve them in order to make sure that we address the disparities issue. So here's just a few pieces of data. This is a study that Brandon Mahal, again, one of our trainees, did, who's now at Sylvester Cancer Center in Miami. Brandon reported that there's a bigger prostate cancer-specific mortality difference in screened eligible men than in screen ineligible men. So the reason this is important is because we set guidelines. Somebody sets guidelines and says, if you are between 55 and 69, you are eligible for PSA screening. And again, this is not the only guideline, but this is one guideline. So you're eligible to have PSA screening. If you are less than age 54 or 55 or over age 70, you are not eligible for screening. And that isn't to say people don't get screened, but the guidelines are telling us that those are the groups that should be screened. So if we look at the people that are not screened eligible, meaning they're too young or too old, we see that the prostate cancer specific mortality differences are fairly small. They're not, the P of 0.06. So, they're not nothing, but they're fairly small. So outside of the range of the screening guidelines, the mortality differences are not huge. But if you look in the screen eligible category, 55 to 69-year-olds, you see a huge difference, that the prostate cancer specific mortality is significantly higher in Blacks versus non-Blacks. And there's a significant interaction between these different groups. And so what this is telling us is that we have guidelines. The guidelines were built around data that largely didn't include Black men. And we don't have a lot of data in Black men. But by not incorporating or thinking about how we develop interventions, we may need to think about it differently, because Black men don't get screened, don't get the treatment and everything as they should. And as a result, even in the places where they are eligible for screening, not that they got screening, but where they're eligible for screening, they may suffer disparities. And so these guidelines, the data, how we guide what we recommend being done, and then how we act on that is clearly very critical. Health system influences are critically important. Again, work from Brandon Mahals and our group that use the National Cancer Database with a large sample set, non-treatment. Many men with prostate cancer don't get treatment. And it's possible that they don't need treatment, not active treatment, that is, because they have indolent disease, they are less likely to need active treatment. However, Black men tend to have more aggressive disease, so you might hypothesize, without knowing anything else, that non-treatment should be lower in Black men because they tend to have more aggressive disease. But you can see that Black men have, in uninsured populations, nearly twice the non-treatment rate of white men, and even in insured populations, a 50% higher non-treatment rate. And that's not what you would guess just based around what we know about the pattern of prostate cancer in Black men. So there are health system, insurance, payer influences that may affect outcomes. Similarly, days from diagnosis to treatment in an academic center or in the community are significantly longer for Black men than white men. And as you can imagine, delays in diagnosis and treatment after being diagnosed can affect your outcomes, can affect the quality of the treatment, the type of treatment you may be able to have. So health system influences and access to care clearly are important. And I guess these data support that, but none of that should be a surprise to anybody because we know that that's the case in our health system in the US. Similarly, we see that treatment disparities are greatest in high-risk disease. So men, this is a comparing more or less likely to have treatment by Black versus white. So intermediate risk disease, they're very similar, but in high-risk disease, the disease that most likely needs treatment or needs to be considered for treatment, Black men are significantly less likely to get that definitive treatment. So this is just what I was saying before. Black men have more likely high-risk disease, but even matching for high-risk disease, Black men are less likely to receive definitive treatment. And that's, again, suggests that access, healthcare patterns, health systems, delays in diagnosis, insurance, all strongly impact on the treatment patterns, but also presumably mortality and survival. We also know, and this is a paper that came out a couple of years ago in a randomized clinical trial, that Black race was associated with lower risk of prostate cancer-specific mortality in non-metastatic prostate cancer in a clinical trial. So this is not the real world, but if you took Black and white men and put them in a clinical trial and treated them the same, their outcome, Black men actually did slightly better than white men. That's both for prostate cancer-specific mortality as well as overall cancer mortality. So again, we don't know in reality what would happen in non-metastatic cancer if we took the similar kind of result out there. But if we can infer that a lot of the mortality differences are due to some of these healthcare systems, social determinants, access, et cetera, because when we equalize those treatments, we definitely don't see the same disparities. Now, obviously, it's clear that not the Black men who got into these studies are not representative of all Black men. There's all kinds of issues with comparing a randomized clinical trial to the general population. But I think it really argues that equal care, equal access will probably matter a great deal in influencing outcomes and disparities. So I'm getting toward the end. I'm going to leave time for questions, but just want to say a couple of things. So when I started the talk, I talked about the differences and inequities that we are worried about. And I tried to present a little bit of data showing you where these kinds of different factors are important in determining the disparities and therefore how we can address them. So I think it's clear that genetics is really important in terms of risk stratification. The problem is most of the genetics that I showed you and most of what we've learned really detects or are associated with incidence of disease, not outcomes from disease. And we have very little genetics that tells us who's going to die of prostate cancer. So while genetics really does distinguish people who will be diagnosed with disease, since so many men are diagnosed with indolent disease, maybe shouldn't have treatment, the genetic data that we have is imperfect. We really would like to have genetic data genetic and genomic data that told us who's going to have a bad outcome. And again, some of the genomics tell us that, some of the germline genetics do not. And we don't have a lot of great data yet in diverse populations to really address that. So there's, it's promising, but not quite there yet. I think it's pretty clear from what I said that self-identified race or ethnicity or possibly ancestry or other metrics are very important, because the disparity is clearly in some groups, and those groups can easily be identified, variety of metrics, but race and ethnicity is clearly something that deserves a lot of attention in terms of risk stratification. The devil in the details is how we choose what that metric is, how we use it, when we use it for specific questions or not. And finally, environment. I mean, I put a big minus there, not because I don't think environment is important, but I don't think so far environment is a really strong stratifier of risk. And that's something that I think, knowing what you're exposed to, what your diet does not sufficiently stratify risk. I'd love to hear people's contrary opinions on this, enough to make differences in how you stratify risk or how you make different management, screening, or treatment decisions. I don't think we have data, and because the work that's been done in this area has been so strong, I don't think it's likely we're going to have a lot of data to guide environmental stratification of risk for prostate cancer. Not true for other cancers, but at least for prostate cancer. Behavior and environment. I mean, I think it's really clear that environmental exposures and behavior probably have something to do with how we can develop interventions. And this is a very broad category, but PSA screening or prostate cancer screening in general certainly can fall under this. And prostate cancer screening is incredibly important. Again, how we use environmental traits, individual lifestyle kinds of factors is still a little bit less clear. But I think there is there are opportunities for interventions in this space. And I think by the same token, there are biological and physiological opportunities for interventions, particularly if we can identify individuals who are at high risk and there may be chemopreventive agents or something that might help us to understand how to intervene on biology or physiology. And part of that really does relate to the fact that there's so much indolent disease. We really need to understand which tumors are going to be lethal. And by doing that, then we can use the biological information about tumor potential lethality to intervene on certain patients and ensure that they don't die of their disease. And I think it's also fairly clear from what I've said, and I'm sure you know, that the consequences of systemic racism in terms of care access, discrimination, segregation, et cetera, are incredibly important, the inequities. And obviously, these are very hard things to fix, but they are likely to create a huge amount of benefit if we can address through interventions the consequences of systemic racism. And again, have to save it for another time how that works, but glad to discuss that because I think that's a key point that we need to have available to us to develop any kind of intervention that's going to ultimately have a population benefit in terms of disparities. So let me just end by this point that cancer health disparities exist at all phases of the cancer continuum, from prevalent disease in autopsy cases all the way up to mortality and everything in between. There are disparities all the way along this continuum. And these disparities are determined by the complex effects of biological, lifestyle, social influences, all access to care, you name it. They're very complex. And so it matters where, the biological effects might be more prevalent or relevant in early disease or in the early phases of the development of disease, whereas it looks like social influences, access to care, screening may have a bigger impact on mortality. And so we need to think about where these factors are acting, what they're acting on, what phase of disease, what parts of carcinogenesis, and then as we begin to think about understanding that etiology, then developing appropriate interventions. So some of these factors may inform risk stratification, other are interventional opportunities, but they all vary by context, timing, and the trait of interest. And so the things that you might do to prevent or intervene on the development of prostate cancer during a precancerous phase is very different than what you might do to intervene to prevent metastases, or might be very different. So the interventions that we develop not only need to be tailored to the person, their individual susceptibility, et cetera, but tailor to the influences and the timing of the effects that we want to think about. So again, it makes it very complicated because it's not one size fits all. We'd like it to find things that one size fits all to prevent death, but that we may need to tailor both the interventions that we develop, the biology we try to understand, to very specific events along the prostate cancer continuum. So I'll just end there. Want to make sure you've seen a lot of the people who are involved in this work, and I appreciate your attention.